6A, plane curves and parametrics. Here we go.
Am I reading the until now? Until now, we have been representing graphs by single equations involving variables x and y. We will now study functions with which three variables are used to represent curves. These equations are called parametric equations.
All right, fantastic. It's not your fault that before today you guys have really been doing things with two variables. You've had an x variable and a y variable, right? What did x do? It moved to the right. It moved to the right. And then what did your y do? Go up or down. That's really how we did it. Now we're going to start talking about parametric equations, which have three variables. All right, and so let's get into it. Here we go. Definition of a plane curve. Thank you so much, Kate, for volunteering to read.
If f and g are continuous functions of t on an interval I, then the equations x is equal to f of t and y is equal to g of t are called parametric equations, and t is called the parameter. We're good. The set of points x and y obtained as t varies over the interval I is called the graph of the parametric equations. Taken together, the parametric equations and the graph are called a plane curve, denoted by C.
All right, fantastic. It's called a plane curve. All right, but does that mean it's a boring or ordinary? No. What does it mean to be a plane curve still? It's on a plane, which means what?
It's 2D.
It's two dimensions. We have three variables, but it's still in how many dimensions? Two dimensions. Okay, that's kind of an important part. All right, so here we go. I need another reader. Thanks, Mariah, for volunteering.
When sketching by hand a curve represented by a set of parametric equations, you can plot points on the xy plane. Each set of coordinates x, y is determined from a value chosen for the perimeter t. By plotting the resulting points in order of increasing values of t, the curve is traced out in a specific direction. This is called the orientation of the curve.
All right, so we're in 2021. We understand orientation by now. So that's what we're going to be talking about. We're going to be talking about the orientation of the curve. All right, so if we have a point here, and then 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 a point here, our orientation, the way I sketched it, is going that way. Okay, and so the orientation is represented by these arrows in which we're moving. So if I were kind of in this spot, let's say right here, this point is going to the right and it's going up. It's doing both of those at the same time. Where this point right here is moving to the right and it's going down. It's doing both of those at the same time. All right? Has anybody ever rubbed your belly and tapped your head at the same time? That's a parametric equation. That's kind of the same thing as a parametric. All right? You're doing two things at once. You're going left and right and up and down at the same time. All right? A parametric equation. So write this one out. So now we have x is equal to t squared minus 4. And we have y is equal to t over 2. And I have the interval from -2 to 3. All right, for my t variable.
I've got an idea.
We're just going to substitute in, Joseph.
Yeah.
All right?
I
All right, so draw out the little table. All right, so we're going to draw out the little table. And so we have our t values of -2, -1, 0, 1, 2, and 3. Because that's what's given by our interval. So if we substitute in -2 in for t, what's my x? 0. And then if I substitute in -2 for t, what's my y? -1. So now I still graph it in like a rectangular form. So 0, -1 is right down there. So now I'm going to substitute in -1 for my t. So what would I get? No, not -3. And then what would be my y? -1/2. So I'd graph -3, -1/2, just like that. And then I substitute in 0. So what would be my t? Or what would be my x? I'm sorry. -4. And then what would be my y? 0. And then I substitute in 1. And what would be my x? -3. And what would be my y? 1/2. So then I plot it right there. And then I substitute in 2. So what would be my x? 0. And what would be my y? 1. So then I plot that right there. And then I substitute in 3. So I get 5 and then 3/2. All right, so I have it right there. Now, the nice thing about a parametric is when we connect the dots, we do it in the order in which we did them. So I go from time equals -2 to then time equals -1 to then time equals 0 and then back again. So I draw these arrows, which represents the orientation of my curve. All right, and that's the really cool thing about a parametric. So this point right here is at time equals -1, right? That point right there. What is my curve doing at time equals -1? It's going left and up. All right? And without parametrics, you don't know that it's going left and up, because before we just went left and right and then we went up and down, remember? We didn't really know what it was doing. A graph never went to the left before. You following me? All right? So now we know that it's going left and up with our parametric. So at time equals 2. All right? So this point would be at time equals 2, right? So at time equals 2, what's the graph doing? It's going up and it's going to the right. Okay? And that would be something that we can tell by a parametric and not necessarily a rectangular. All right? Now, at time equals 0, it's doing something kind of important. And when we take Calc 2 or Calc BC, this will be something that we talk about. What's it doing at time equals 0? It's not going right and up. It's turning, which means is it going left or right? No, it's just doing what? Still doing something.
Going up.
It's just going up. All right, it is not going left or right at time equals 0. It is just going up. All right, and that's kind of one of those interesting points. All right, or interesting times, I guess. Now we're going to talk about eliminating the parameter. And in pre-calc, this is where I spend the bulk of my time. All right, yes, we're going to do it again in Calc 2. In Calc AB, we don't deal with parametrics, but in Calc BC or Calc 2 in college, you will deal with parametrics again. All right, so this is where I'm going to spend the bulk of my time. In pre-calc, it's called eliminating the parameter. And the parameter is either t usually. All right, it's that third variable. Okay, so I have the same equations as I did before. I have x is equal to t squared minus 4, and I got y is equal to t over 2. So I want to eliminate the t. All right, that's called the parameter. So I have to solve for t in one of these equations. Now, which one's it easier to solve for?
Y.
It's easier to solve for in the y equation. You following me? So what does t equal? T equals 2y, because I multiply by 2, right? So now I have 2y for t. So all I do is substitute in 2y in for t in the other equation. So when I do that, I'm now left with the quantity of 2y squared minus 4. And I am totally cool to leave it right here. X is equal to the quantity 2y squared minus 4. You can keep going, so then we have x is equal to 4y squared minus 4, right? Well, what is 4y squared minus 4? X equals 4y squared minus 4. What is that? We know this shape. It's a parabola. And which way does it go? Does it open right or does it open left? It opens to the right. And it went back to -4. And so that would be the graph of this rectangular equation, is it not? Which is the same thing we saw before. However, does a rectangular have orientation on it? No. I don't know which way it goes. I don't know if it moved left and then up and then right and so forth. All right, so which one can you tell more by? A parametric or a rectangular? A parametric. You can tell more by a parametric than you can a rectangular. All right. I have x is equal to 1 over square root t plus 1, and y is equal to t over t plus 1. The domain of it is really t is greater than negative 1. I'm not so concerned about the domain of these things. I might talk about them, but I'm not going to test it. All right. So what we're going to be doing is we're going to be eliminating the parameter. That's where I want to spend the bulk of my time on parametrics. All right. So we need to solve for the parameter of one of them. Now, which one is it easier to solve for t? The x equation or the y equation? Which one? The x. Why is the x the easier one to solve for? It only has one variable. The y has how many? 2. It's going to be very difficult to do that. All right? Actually, almost impossible here. All right? So, we're going to solve for t in the x equation. Now, my first period class went a different way to Tampa than what I have posted, and I liked it. I liked that way, actually. All right? So, what do you want to do?
Multiply the square root.
Let's do it. Multiply by square root t plus 1. Let's do it. So, now I end up with
X times square root t plus 1.
is equal to 1. All right? This is the way first period did it, too. That's nice. So, now what? Divide by x. So now we're going to divide by x. So now I have square root t plus 1 is equal to 1 over x. Now what? Not square root, but now we square both sides. All right, so now we square both sides. So now I'm left with t plus 1 is equal to 1 over x squared. All right. Now what? Subtract 1. So t is equal to minus 1. So now I solve for that parameter. So now I'm going to take 1 over x squared minus 1, and I'm going to take this, and I'm going to substitute it in for t on that other equation. So now I end up with y is equal to 1 over x squared minus 1 over minus 1 plus 1. And then this is something beautiful that happens. What's something beautiful that happens? The ones cancel on the denominator. All right, so those go away. Now I have a complex fraction still, a fraction. So what would I do? Okay, how do I cancel them out? I multiply by x squared over x squared. All right, we just need to manipulate the way it looks. All right, ladies are good at it, guys need to catch up. So what happens in my denominator? It becomes 1, so that's beautiful. So when I distribute my x squared up top, I end up with y is equal to 1 over x squared times x squared is just 1. And then minus x squared. All right, 1 times x squared is just x squared. So my rectangular equation, when I eliminated the parameter, is just y is equal to 1 minus x squared. And what I need for this year, I'm good with it right there. Does everybody hear me? Okay. So 1 minus x squared is a what? It's a parabola. And which way does it face? It goes down. It goes down. All right. So that's really what I want to do for this year. So now I have x is equal to 3 cosine theta, y is equal to 4 sine theta, and I have the interval 0 to 2 pi. I think this one's fantastic. And we're going to eliminate the parameter to find a rectangular. Now, what's my parameter in this case? It's not t. What is it? It's theta. So I can kind of want to solve for a theta, right? And so if I just picked my x one, I'd first divide by 3, but then I have x over 3 is equal to cosine theta, right? And then I arc cosine it. Then it's just going to get disgusting. All right? And so I don't really want to go down that path. So if I see sines and cosines, I learned something before in chapter 5, section 2, with sines and cosines. What was that one formula that I had you guys memorize? That one formula. Good. Sine squared plus cosine squared is equal to 1. So there's my Pythag identity coming up again. All right? And so I can solve for either sine or I can either solve for cosine. And so x over 3 is equal to cosine theta. And what would sine theta equal? Y over 4. And so now I'm just going to take these and I'm going to substitute it in. All right? And so now I'd end up with y over 4 quantity squared plus x over 3 quantity squared is equal to 1. Well, if I distribute this, I'd end up with y squared over 16 plus x squared over 9 is equal to 1. What kind of equation did I just make? I made an ellipse. Exactly. I made an ellipse. And where is this ellipse centered at? It's centered at 0, 0. And which way is it going? Is it elongated vertically or horizontally? Vertically. Why? The bigger one's underneath the y. So what is my a? 4. My a is 4. So I'd be going up 4 to get to that vertice. And then I'd go down 4 to get to that vertice. And then what would be my b? 3. And so this actually creates an ellipse. All right? Now, I want to show you the orientation of it going back to my parametric. It's between 0 and 2 pi, right? I'm putting everything together right here. It's going to be beautiful. All right? So if I substitute in 0, what's cosine of 0? Oh, crap, guys. Chapter 4. Come on. What's cosine of 0? Guys, we're going to do polars tomorrow, and guess what? We're going to need to know our trig again. So what is the cosine of 0? 1. Cosine of 0 is 1. So then 3 times 1 is 3. So my x is 3 first, right? And then if I substitute in 0, what's sine of 0? 0. So 4 times 0 is 0. So guess where it starts out at? It starts out at 3, 0. Now, I'm going to say this is pi over 2. Remember, this is pi over 2 and this is pi, right? So, if I substitute in pi over 2, what is the cosine of pi over 2? 0. Good. So my x is now 0. What's my y? My y is going to be 4. And so my orientation means it's going that way. And then guess what? It travels that way, and then that way, and then that way. All right? So that's actually the orientation of this ellipse. Looking at it, just x is equal to 3 cosine theta and y is equal to 4 sine theta. Did you think it was going to be an ellipse? No, but it is. All right? It's beautiful. All right? Pretty nifty? What's it doing at theta equals pi?
Just going down.
It's going down. That's it. All right? What's it doing at theta equals 3 pi over 2? It's just going what?
Right.
Just going right. All right? It's just going right. I like.
If it's on like an axis, whether it be like the y or the x, it's only moving like in one direction.
In these it is, but not necessarily. All right? Here we go. So now we're going to find a parametric given a rectangular equation. And this is honestly probably the easiest thing that's going to be on your test next Tuesday. All right? This is probably the easiest thing. So I have the equation y is equal to 1 minus x squared. And that's a rectangular equation because how many variables does it have? 2. And so now we're going to take 2 variables and we're going to make 3. We're going to have an x of t and a y of t. All right? So it has to give us something. And the something that this one gives us is t is equal to x. So what does x equal? X equals t. Hey, I made part of my parametric already. Very nice. All right. So now that I know x is equal to t, I'm going to take this equation and I'm going to substitute in what? T for x. So now y is equal to 1 minus t squared. And we're done. All right. Pretty hard? All right, let's do it again. So now I have t is equal to 1 minus x. All right. So what does x equal? 1 minus t. All right, so we're halfway there. So now what am I going to substitute in for this x? 1 minus t. So now I end up having y is equal to 1 minus the quantity of 1 minus t squared. And I personally am okay with you leaving it right there. All right. Am I going to take off if you FOIL, distribute the negative, combine like terms? Am I going to take off for it? If you do it correctly, I'm not. All right. But I am personally okay if you leave your parametric just like that. All right. Pretty good in the hood? All right. Is page 774, numbers 5 through 25 odd, and 41 through 47 odd. Now, I only need you to graph number 5. The only graph that I need you to do is number 5. All right, so on number 7 through 25 odd, just eliminate the parameter. All right. All right. So on 7 through whatever, I don't think you have to do part A. Just do part B, eliminating the parameter. Okay?